Sir, you are not audible.
Hello, am I audible now? Sorry for the inconvenience. We'll just start with the important concepts that we had to do. So, few important concepts which we have to. Um, yeah, I think so. Now I'm audible. So, a few important concepts. One is the Coulomb's law. Basically, Coulomb's law is the main formula which you need to know. These are like the important thing. So, what Coulomb's law states that the like charges repel each other and unlike charges attract each other, and the force that acts between the two charges is given by the equation 1 by 4 pi epsilon naught q1 q2 upon r square, where q1 and q2 are the intensity of the charges, and r is the distance between the two charges, and 1 by 4 pi epsilon naught is a constant. The value of the constant is given here below. So we'll move to the next important thing. This is the Gauss law. Basically, when you have a charge kept in space, the flux that is generated by the charge at distance r from the charge is given by the Gauss law formula. So the Gauss law formula is q upon 4 by epsilon naught r square. Now, moving to the next formula, this is the capacitance formula. So basically, when you have capacitor of when you have a capacitor with the plate area of A, and the two plates are separated by distance d, the capacitance is given by epsilon naught r into epsilon naught 0 A upon d. Epsilon naught 0 is the vacuum permittivity, and epsilon naught r is the relative permittivity between the medium and the vacuum. So that is how the formula is placed. So this is an important formula. You need to know uh, this formula for your exam. Again, the next important formula, that is the pulling voltage. So basically, what happens is, uh, so whenever a capacitor is being capacitor is functioning, there are two types of forces that are in place. So basically, as I said earlier, the unlike opposites attract. So basically, when both the plates are at opposite um, are having opposite charges. So there, uh, if the intensity of the voltage increases beyond a certain point, which there will be like the pull-in will happen between the two with plates of the capacitor. So the pull-in voltage is basically given by this formula. So uh, is basically you find the equilibrium point between the two voltages, and so the pulling distance is basically d by 3, and the pulling voltage is given by the formula root over 8k dq upon 27 epsilon naught A. So that you need to know. Stiction, basically another concept. So basically, when you have a silicon wafer, so this basically stiction is a phenomena that happens at a very small scale. So you won't be experiencing it at a very high scale. So basically, it happens at the micro scale basically. So when you have a silicon substrate, and when the distance between the like the substrate and what you are doing, the maybe a cantilever or something which are making on the silicon substrate, if the distance is too less, sometimes there will be like contact will happen between the two objects, and it will be like that there is no force actually causing that contact, but that is just the contact is happening between the two, the substrate and the structure. So there will be like beam or something. So that contact will be happening. So that is something which you need to remember. So if the if the length of the beam is too high, then the chances of restriction will be higher. So that is something which you need to know. It is not there. You won't be asking any numerical on it. Just this is just for your information. So hope all the concepts are clear. We'll move to the practice assignment. If you have any questions, please unmute yourself and ask. I'm not seeing any questions in the chat or in the by anyone. So we just move to the with the assignment. So the first question is: four particles, each with charge q, are placed in the corners of a square. Another charge q of a big Q of opposite sign is placed at the center of the square, such that the total force on each four particles is zero. Which of the following relation is correct regarding the charges q and q, big Q and small q? So we have a situation where we have a square at the boundaries of which we have um, small charge q. So maybe we can assume that the small charge q is negative, and and the other we have and it is in equilibrium with a single big charge q that might be a positive charge, and we have to find out what is the value of small q and big Q, so that the entire thing is in equilibrium. So you need to solve it. So first, just take a square and you place q at all the four edges, and you put the big Q at the center. So now what is happening basically, take Coulomb's law. So based on the Coulomb's law, you take the force. One thing you have to do is you have to take out the concept of symmetry. So what is happening with so Q placed at the edge C is equal to the what is happening with all the four Qs. So now we are only focus on basically OC, the uh, what is there in the figure OC. So now, based on that, we basically go to find we use Coulomb's law, and we solve it. So basically, we apply the entire scenario along only OC, and then we take out the your answer. So basically, the force between, so you resolve first the force at C. So you get F1, F2, F3, and F4. Then you first find out the you have the you already use the Coulomb's law, and based on the Coulomb's law, you basically find the value of Q. So these are the calculations how you do it. So basically, the first is F. You find first is F1. So since F1 is basically at 45 degrees from the F1 and F2 are along OC by symmetry. So basically, you get the resultant of F1 and F2. So you get it as root 2 F1, and F3 and F4 are basically acting along the OC line. So that is how you get it. Uh, Using that formula, this is the answer. Anyone who could not get the calculation here? Okay, so the answer is B. Q is equal to 0.96 small q. So anyone who could not get this answer, could not get understand this calculation, please let me know. Okay, fine. Since nobody is unmuting themselves, we will move to the next question. So we have the question number 2: capacitance of two concentric metal shells with radii A and B, where A is greater than B, is given by So we have four options: C is equal to 4 pi epsilon naught AB B minus A. C is equal to 4 pi epsilon naught AB B plus A. 4 pi epsilon naught A square B square upon B square minus A square. 4 pi epsilon naught B square A square B square upon B square plus A square. So basically, we already know the formula for capacitance. So now this is how we get the um, capacitance. So basically, we know what K is, so we eliminate K. So then we find out what is the potential at outer sphere. So basically, just to uh, give you I'll just draw it for you. So based on this, as you can see, you may be able to see the spherical shells. So we find the potential at each of the cells. So basically, we use the equation Q is equal to CV. In this, we are finding V is equal to Q by C. So using this, we find the two formulas. We find the potential at both the formulas. So then we find the potential difference. So that is the potential difference at this plate, between this plate and this the second plate. We find the potential difference here, and then we just again put the formula Q, C is equal to Q upon V, and then we get the final answer, that is C is equal to 4 pi epsilon B A upon B minus A. Anyone not able to follow, please unmute and ask. So the final answer is A, C 4 pi epsilon naught AB upon B minus A. Anyone not able to follow, please let me know. Okay, so the next question is, choose the correct option in case of parallel plate capacitor with overlapping distance of x. So we have the force given. So basically, the normal force and the tangential force, transverse force. Basically, they have given that, and the second in the second option they have given if x. Basically, x is the uh, distance between the so D is the like the distance between the two parallel plate capacitors, and X is the overlap distance. So if X is way greater than the D, transverse force will be greater, lot greater than normal force. So we have to choose the what is the correct answer. So whether it's the statement one is right, only two is right, both A and B, both one and two are correct, or none of these is correct. So uh, the first formula, basically we need to find out the normal force. The formula for normal force is given by bx epsilon naught 0 epsilon naught r v square upon 2d square, and transverse force is given by b epsilon naught v square upon 2d, uh, and uh, so we have the normal force as kx by d, and transverse force kx by d, and the transverse force is k. So if x is way greater than d, so x by d is greater than 1, so normal force will be uh, very much greater than the transverse force. So the answer is only one is correct, since because we'll find that the normal force is greater if x is greater than d. So here they have given us a opposite relation. So the answer here is A. Only one is correct. Anyone not able to follow, please interrupt me or put your doubts in the chat box. We'll move to the next question. Electric discharge density of a parallel plate capacitor, plate area A, gap between the plates D, if the electric field inside is E, is given by half epsilon naught E, half epsilon naught E squared, half 1 by 4 epsilon naught E square, 1 by half epsilon naught E square. E cube, sorry. So we all already know that the charge basically we have a charge is given by E epsilon naught E into A. So basically we need to find the charge energy of a charge plate capacitor. So energy is given by this formula, half Q square by C. But we already know that C is epsilon naught A by D, that is the capacitance. So by putting everything in the formula, we get the option as uh, 1 by 2 epsilon naught E square AD, but A is basically the AD is the volume between the plates. So basically, we need the charge density, that is the energy upon volume. So then we divide it by the volume, and the answer we get is 1 by epsilon naught E square. So the answer option B is right. So moving to the next question. So this is a very important question. Please follow this question like in detail, and maybe take screenshot if you need. So you have a schematic of a incline accelerometer. So accelerometer is basically you are using it to measure the acceleration with a crab-like suspension. So you can see here these are the four fixed points. So these are the four fixed points. Okay. So now what will happen is depending on the movement. So if the acceleration is happening, if this is moving here, so what will happen? This will be again stable. So this is again a stable. This is also fixed. This is again fixed. So now what will happen is if the car is moving forward, what will happen is um the distance between, so the entire thing, this structure will move forward. So what will happen is this from the gap here will increase to gap here. So the gap will go on increasing. So that will since the change in capacitance will then you can that will be correlated with the acceleration. So now the details are given. So I've explained you how the accelerometer is working. So now coming to this question. So basically assume the entire cylinder. So anyway, it will be made up of silicon. So any sensor in MEMS will be made of silicon. So the Young's modulus is 169 gigapascal. The thickness is 25 micrometer. Each square in the grid has 5 micrometer into 5 micrometer. In order to perform a self test, how much voltage needs to be applied to get a displacement of 5 nanometer? Deflected beams AB is neglected, and the top fixed component C1 is not connected to the circuit. Okay. Uh, you could understand the question. Anyone has difficulty understanding the question? So now, as I told you earlier, you when the acceleration happens, you will see the change in distance, and then the change in distance is leads to change in capacitance. D change in D leads to change in C, which gives us the value of acceleration. But now, first we need to calibrate the sensor, right? To calibrate the sensor, what they are asking is how much voltage should we apply here. So how much voltage should we apply so so as to get the displacement of 5 nanometer? So let's get into it. So basically here we have I've solved it by my hand. So this is how the thing is. So we know the value of energy is basically n epsilon naught b. So uh, b into t upon d. So where uh, and we need, so basically we have two forces. We have the spring constant basically of every system, and we also have the force acting on it. So first, what we do is we find out the spring constant of the entire system. So the entire spring constant is basically four into, we have four springs acting here. So we divide it into four springs, so we get the entire system equivalent spring constant. So once we get the equivalent spring constant, we correlate it with the voltage. So the spring constant, b is the 5 nanometer basically, d is the distance between the two plates, and t is the thickness. So t is the basically the this this value is called as t. T is the basically the exposure between the two plates, and based on that, we get the value of the uh, voltage that has to be applied. So the voltage is 538 volts. Anyone did not understand this question? So this is a very important question. It is in your practice assignment. Anyone who did not understand this question? So these questions are calculation heavy and understanding is a bit tricky. So anyone who did not follow them, please let me know, else I'll move to the next question. Okay, since I'm not getting any response from inside, so this is the equation that was this is the assignment that was asked last year. So this is the previous year assignment. So here we have two charges. One is Q1 and 3Q, placed one meter apart. So these are the like charges. So these will repel each other. Charge Q, that is a negative charge Q, is put between the three charges, so that all the three charges are in equilibrium. So how will you do it? So how will you place it so that everything is in equilibrium? So Q, so these are the four configurations they are saying. Q is placed at 0.634 meter left of Q, and Q, the value of big Q, is basically 0.535 of Q. So same, the second option is Q is placed 634 meter to the right of Q1 Q, and the value of Q is 0.535 Q. Then minus Q is placed at 0.366 meters from the right of Q, and Q is 0.402 Q, and the last option is minus Q is placed at 0.366 meters to the right left of 3Q, and the value of Q is Q is equal to 402 Q. So first we have to find that they are in equilibrium. So basically the forces that are acting. So we just put uh, the force that is acting on for so we'll just take one point. So what we'll do is uh, we'll take the value of q. So q is what we have to find where we are to place minus q, the negative charge. So we first find the force on it because of the small q, that is we are assuming as f1, and then sorry, that we are assuming as f2 in due to the 3q we are assuming it as f1. Now one thing and then we are just putting it where the we are just putting it this way. So basically we have put q as the center as x is equal to 0. 3q we have put at x is equal to 1, and then we have to find out minus q. So we are just assuming that minus q is placed at the right of q. So basically we are assuming that q has been placed here. So the for equilibrium, F1 F1 plus F2 has to be 0. So we use the formula of F1. F1 is kq upon x 1 minus x, and uh, uh, so F3 is equal to 3q. So basically the k 3q um, q upon 1 minus x the whole square. So then by using this equation you get this quadratic equation. So you can keep x is at 0.366 and minus 1.366 meters. But because if we keep at minus 1.366 meter, it will the not be feasible because it will be out of the charge region. So that is why we are selecting the value of 0.366, because it's a negative charge. It has to be in the center of the two charges so as to get the equilibrium. So, and then based on that, we again substitute the value of big Q in the distance formula to get what is the magnitude of Q, so as to get the equilibrium. So then we get the equilibrium value of big Q as 0.402 Q. So the answer is C. Q minus negative q is placed at 0.366 to the right of q, and q is equal to 0.402 q. Anyone not able to understand this, please let me know. Okay, so we move to the second question. So we have here the two beams. You can see the dimensions. One is 200 micrometer, the other is 200 micrometer. The overlap distance, basically the distance between them, where there is a overlap, is 120 micrometer, and the distance between them is 4 micrometer. So the normal force between the two plates, capacitor plates, is given by um, epsilon naught bx v square upon 2d square, and tangential force. So basically normal force is acting. So basically normal force is acting in this direction, and transverse force is basically tangential force, basically acting in this direction. Find the relation between the normal force and tangential force in the sir. Uh, we have to find the relation between the normal force and the tangential force. So these are the few options. Normal force is 30 times smaller than the tangential force. Normal force is 30 times larger than the tangential force. Normal force is 50 times smaller than the tangential force. Normal force is 50 times larger than the tangential force. This is one of the simplest examples because you know you have everything given here. So just substitute everything and you get your answer. So this is how you substitute. So everything else gets cancelled. So what remains is basically x and d. So x is the overlap distance and d is the distance between the two. And the value you get is normal times is the normal force is 30 times greater than the tangential force. So the question may look difficult, but you can see that the question is one of the most easiest questions given here. So even the formula is basically given there. So moving to the third question, mark the incorrect statement. Stiction often occurs when the sample is dried after wet etching process. Stiction may be prevented by decreasing the thickness of the beam. For stiction to occur, the adhesion force between the beam and the substrate should be lesser than the elastic restoring force acting on them. Stiction is caused by primarily by capillary action due to surface tension. So we have to mark the incorrect statement. So read this carefully when you are doing it. You have to mark the incorrect statements. So I'll again explain stiction to you, just so that you can answer the question yourself. Okay. So you are having a silicon wafer here. Okay. So after silicon wafer is there, so what is the first step in photolithography? So basically first step is you basically put the resin. So you first activate the surface, and you put the resin here, and then basically after the resin has been put, you mask it. So you use a mask, and based on the mask you get some features. So you do etching and everything, and then you get some features. But these features are basically not enough. So what you will do is, you will have to make beams and other things which are freestanding. So here you make a sacrificial layer, you put a sacrificial layer, and then you will do PVD on CVD. So that is the physical vapor deposition or chemical vapor deposition. So after that you will get one of the beam like a structure. So now what is happening is, just to show you one single beam in motion. So this is the beam that has been created. We remove the sacrificial layer, and this is the wafer. So now what we have to do is, if the what is happening is, due to the like due to very less gap between them. So the distance what we are looking here is basically in the nanometer range. Nanometer maximum 1 micrometer, 2 micrometer range. That is the maximum which we are looking at. So we are looking at the structures in nanometer range. So what will happen is, these structures will tend to stick to each other. That phenomenon is called as stiction. So when do you think the stiction will be more? So if we have the beam thickness is very high, um, and it is able to stand on its own, if it is, will there the stiction be high, or when the beam is very thin, and then it is just collapsing on its own, and so whether the thickness is higher. Um, can you prevent it by decreasing the thickness of the beam? Is one of the questions you need to ask. And so basically the second is caused due to addition force between the beam and the substrate should be lesser than the elastic restoring force uh, acting upon them. So that these are the questions which you need to ask. So what do you think will be the answer? So the answer is, basically if you have a if you reduce the thickness, so basically it will be more prone towards actually sticking to the substrate. So the if we reduce the thickness, the stiction will increase, not reduce. So this is one of the wrong statement. And again, addition force between the substrate should be for stiction to occur. So addition force should be more than the elastic restoring force. If the restoring force is high, it will the stiction will not occur. So these statements are the wrong statements. Anyone has any questions? So we move to the next question. You are given three statements. Statement one: methanol is high surface tension liquid. Using methanol reduces capillary pull down force. Statement three: methanol is used in the final rinsing step to overcome stiction. So choose the correct option. All statements are true. Statement one is correct explanation for statement three, but statement two is not the correct explanation for statement three. Statement one is false, but statement two and three are true. True. Statement three is the correct explanation for statement two. Statement one is false, but statement two and three are true. Statement two is the correct explanation for statement three, and the last is all statements are false. So this is basically like GK type of question. So I would request answer from your end also. So what what are your guesses, please? Okay, so since I'm not getting any guesses from your end, so the answer here is answer is C. So basically, methanol is a low surface tension liquid. So basically, surface if a surface tension is quite high, what will happen is the it will be very difficult to rinse it off. Okay, but methanol is basically we all know methanol is very commonly used in cleaning applications. So basically, when you are cleaning application, you have to use the low surface tension fluid, not high. So basically, what will happen is methanol will be used basically if uh, there is if the surface tension is high, the liquid will tend to stay on the silicon wafer. So we always need something which has a low surface tension. So that is why we are using methanol, and it because of the low surface tension, it reduces the capillary pull down force, and that is the reason it is used in the final rinsing step, so as to reduce the stiction in the setup. So this is the answer. So answer is C. Any questions? Okay, so we'll move to the next question. You have a micro cantilever MEMS switch. So here you can see this diagram of a switch. So it has been fabricated. So basically, you have a silicon wafer on which, as I said, through etching and through PVD, one this micro cantilever beam has been fabricated, and then there is a capacitance that has been developed. So the operational voltage is 0 to 5 volts. Find the range of potential difference that can be applied between the cantilever to make the circuit on from off state. So on state would be basically when when you have a switch type of thing. So what will be the on state? So when the on state will be when there is a contact between the two, right? So the length of the cantilever is 200 micrometer. The width and height of the cantilever is 5 micrometer and 2 micrometer respectively. Young's modulus is given 169 gigapascal, and the gap between the two. So basically, the gap between the two is given here. So, and the questions and the options are here. Circuit will be on if the potential difference is between 2.658 to 5 volt. So, circuit will be on if potential difference is between 0 to 2.658 volt. Circuit will be on if potential difference is between 0.125 volt, and circuit will be off if potential difference is between 1.125 to 2. So we in the starting, I introduced you to something as a as the pull-in voltage. So what do you think will be the right? Okay, we will not go into the specifics first. So I want to understand how many of you understood the concept. So we are like playing as a 50-50. What do you think can be like which options will be right? So A and D will be right, or B and C will be right. So either like A and D will be right, one among A and D will be right, or one among B and C will be right. So as a 50-50, uh, which one would you choose? So AD or BC? So I just want you to understand, I just want to know your understanding, how much you understood the pull down voltage. So can you just give out? So we are just playing like 50-50 here. So whether we are, you think A and D option might be between A and D, or option might be between B and C. So from that, I'll come to know how much you understood about pull-in voltage. So just 50-50 here. Just give your answer whether you think it will be among A and D or B and C. So I'm not getting any option from your end. So I'll just move ahead. So basically, for the circuit to be in on state from off state, the potential difference applied across should be more than the or equal to the pull-in voltage. So now we have to find out what is the pull-in voltage. So basically, the we have already have the pull-in voltage formula. We know the formula for K. K is Young's modulus into width into height cube upon 4L cube. So and we already have the pulling voltage formula, which is substituted, and the pulling voltage is 2.658. So the answer is circuit will be on between 2.658 to 5 volts. Basically, pulling will happening, and there will be contact between the cantilever and the contact, and that will lead to the circuit coming in on situation. I hope you understood this. Any question, you can please let me know. So the next question is capacitance of two coaxial cylinders having permittivity epsilon naught, radii A and B, and length L is given as. So 2 pi epsilon naught L, ln A by B, 2 pi epsilon naught L, B by A, 2 pi epsilon naught L, ln B by A, 2 pi epsilon naught A by B. So now capacitance. So to find out the capacitance, basically we use the Gaussian principles here. So Gaussian principle states that within the surface, ds the charge is q by epsilon naught. So q is already the charge that has been given. Uh, Epsilon naught is 2 pi. 2 pi L. So ds we integrated over the entire surface length. So we got the answer as q upon 2 pi RL into epsilon naught. So now to get the capacitance, we find out the voltage. So for to get the voltage, we integrate the field over the over. So just to explain it to you, what we have done is we have two cylinders. This is A, this is B. So now first what we did is we found out the Gauss the first we integrated over this length, and we found out what is the electric field over this length. So we found out this electric field. We this is what we have got as E. So now to find out the voltage, we integrate this electric field over the distance. So we integrated between A and B, and once we get the electric potential difference between the two plates, then we substitute it in the capacitance formula. So what we get, the answer is 2 pi epsilon naught L upon ln B by A. Okay, so anyone has any questions? We move to the next question. Capacitance. So the answer is C. 2 pi epsilon naught L ln B by A. So the next question, question 7. For a system given below, find the ratio of displacement if the voltage applied across the plates is 4 volt and 10 volt respectively. Uh, the tangential force on each plate of the parallel plate capacitor is given by um, ft epsilon naught epsilon into epsilon naught bv square upon 2d. So basically we need to find out, we already have the um, like the voltage is given, the formula is given, we just have to substitute in the formula. So tangential force, we already have the formula kx. The tangential force is equal to the spring force. Basically tangential force is the force acting in this direction, and we need to find out what is the displacement. So we have to find out what is the displacement of the spring. So we have ft and uh, fs, that is the spring force. We just find out the um, equilibrium position, and then we just substitute all the formulas, and what the answer which we get is basically 0.16. So the displacement is ratio of displacement is 0.16. So just look at the like the calculation. So first did we found out the tangential force. So since we have two plates, we are having 2 into the tangential force, and then we find out the relation between the spring displacement and the tangential force, and then we take both the cases, the case of 4 volt and the 10 volt, and then we get the relation between the two displacements, that is 0.16. Anyone who couldn't understand this? So now moving to the eighth question, consider a parallel plate capacitor whose capacitance is given by C, uh, where A is the area between the plate, area of the plates, D is the distance between them, epsilon is the positive.
So,
Yeah. Hello.
so the previous problems,
Yeah.
just I want to see the last part, sir. After calculating the force.
Yeah. So you get the tangential force. So tangential force acting on one plate. Okay. So this is the FT that is acting on one plate. So since we have to find out both the plates, right? So we are
Okay.
multiplying it by two,
Okay.
and based on so here so that so the tangential force and the spring force have to be in equilibrium. So basically, based on that, we get the relation between x and the voltage. So these are the constants. So basically, these are constants. So this is the spring displacement, and this is the voltage applied. This is the applied voltage is the V1, right?
Sir, one more time, sir. Once the circuit diagram, sir, which is called the tangential force. I want to
Okay,
see the.
okay. So anyone, any plate. So yeah, that's what you should. I'll just go in like I'll just understand. I'll give you a like in deep. So this is the just imagine this is the two plates. This we have two plates. This is the
Yes,
normal
sir.
force, and this is the
Okay.
tangential force, right?
Okay.
So now, in this case, what is happening is you can go here. So we got we have to we get the tangential force between the this set of plates and the lower set of plates, right?
Okay, sir.
So we have two tangential forces. So when what we have to find out is basically tangential force acting between this pair of capacitors, and tangential force acting between these pairs of capacitors.
Okay,
Since
sir.
the distance is the same, the force will be equal. So force at the upper plates, upper set of plates, like this set of plate 1 and plate 2, the uh, tangential force will be equal, because the all the other parameter, the voltage is the same, the distance
Yes,
between the two. Yeah. So now to be in equilibrium, so basically tangential force and the spring force is basically acting in the opposite direction. Spring is pulling it apart. So basically what happens is the tangential force is moving it. So let's explain it with the figure. So what is happening is tangential force is moving it in this direction. Okay. And
yes,
whereas
sir.
the spring force is trying to bring it back.
Okay.
Okay. So now we got the equation between, so the spring force Fs is equal to Ft. So because to keep it in equilibrium, the force which is pulling it apart and which is bringing it back has to be in equilibrium, right? Has to be equal. Else, so to like if any like pulling and pushing force has to be equal, so as to get so as to the object be in equilibrium, right? So now to be in equilibrium, we are using this equation, that is Fs upon Ft. Fs is equal to Ft. So that is the spring force is equal to the tangential force. So in this equation, so Fs is given by kx. So this is the spring constant. This is the displacement of the spring. So now what we need to find out is the ratio of this displacement, and we have this tangential force formula given here already. You can see here. So now what we have to find out is how if we change this voltage, what is the relation between the displacement and the voltage? So now what we'll do is we'll find out the theoretical relation. So we'll just substitute here. So we just substitute everything here, and yeah, we get the relation between k. So k is the displacement in the first condition when the voltage is 4 volt, and x is the volt. So basically we found the relation between the displacement and the voltage. So displacement is x, and this the entire thing is v epsilon naught k by d is constant. So what we found out later, the relation is displacement is proportional to the square of the voltage. That is what we found out. So now we have two cases. One is when the voltage is 4 volt, and the other case where the voltage is 10 volt. So then we substituted it at both places, and then we get the relation, the ratio between the displacement. So basically, when the uh, displacement is at 4 volt, the displacement is around 16 times. Whereas the when the displacement when the voltage you are increasing to 10 volts, the displacement becomes 100. So this is just the ratio kind of thing. And so then when we get the ratio between the two cases, the ratio becomes 0.16. Were you able to follow it? If not,
Yes,
I'll
sir.
explain it again.
Yes, sir. I understood, sir.
Okay. So moving to the next question. So this is the question. Consider a parallel plate capacitor, and the capacitance is given by this formula, where A is the area of the plates, D is the distance between the parallel plates, epsilon naught is the permissivity of the free space, epsilon is the dielectric constant of the dielectric medium between the plates. The capacitance is doubled. So now you want to find out how will you double the capacitance if you increase the distance between the parallel plate. That is sorry, the distance between the parallel plate is half, that is d by 2. The area between the of the plates is a is double. The dielectric constant, you change it to 2, or the distance between the parallel plates, d is double. So whether you reduce the distance, you multiply the distance by 2, you increase the area, or you just change the epsilon naught, you just change the dielectric constant. So what all the cases? So you have the formula here. Just read the options. What do you think will be the? This is a MSQ question. So
Sir, A, B, and C, sir. Uh, A, B, C, sir.
yes, correct. So the answer is A, B, and C. So you can look into the conditions here. So you use the capacitance equation given here. You change the capacitance, you get the capacitance as double. When you uh, area, you make it you make the area twice. Again, the capacitance is double. But if you if you make the epsilon naught 2, again the capacitance is double. But if you increase the distance, basically the capacitance changes, becomes half, because the it is inversely proportional to the capacitance. So that is the answer, A, B, and C. So these are the true and false type of questions. So pull-in voltage of the cantilever beam as shown in the figure does not depend on the thickness of the beam. So it is whether do you think it is true or false? So you have the pull-in voltage equation. So do you think it is basically for pull-in voltage, you have the restoring force. Um, so basically the electrostatic force that is trying to pull since the both the plates are opposite of opposite charges, when the charge between them increases, obviously the unlike charges try to attract each other. So now for the plate have to be in equilibrium, the restoring force, that is the spring type of energy that is that depends on the stiffness of the cantilever beam, has to be more than the electrostatic force. So do you think um, the pull-in voltage does not depend on the thickness of the beam? Is it true or false? So I've given you a hint. The restoring force depends on the stiffness of the beam. The stiffness depends on the thickness. So do you think the pull-in voltage depend on the thickness of the beam or not?
It depends on the thickness, sir. So it is false.
So the answer is false. Yes, exactly. So this is how the what is the formula for pull-in voltage? This is the formula for stiffness. So the pull-in voltage depends on the stiffness constant. So again, the last true and false. If the gap is half, the pull-in voltage decreases or increases. So again, you have the formula for pull-in voltage. Actually, I think this will help you better. You have the formula here. So what do you think? So as per this formula, pull-in voltage is proportional to
Decreases by
Q.
2 root 2, sir. 2
Three,
root 2.
yeah. So do you think the if the gap is half, pull-in voltage will decrease? Yes, the pull-in voltage will decrease. True, because this is the relation between them. So the if you half the voltage, pull-in voltage will also decrease. So we completed these assignments and like the practice assignment and the previous year assignment. If you have any doubt, please unmute and ask.
Sir, sir, at the beginning there was one problem with the checks, checks, sir.
Ah,
Uh,
yeah, yeah, yeah. This is a favorite question. This is yeah. So I'll just maybe I'll just give me a second. I'll just
this
refresh
is
it.
the problem, sir.
Is
Now, what will be the n value, sir? Is it? I want to see the original
yeah,
figure,
yeah, yeah,
sir.
yeah, yeah. I'll just give it to you. Just a moment. I'll just reshare my screen. Just one moment. Huh? So first, just we'll have a look at this figure question, like the figure from this end.
Sir,
Uh,
now, mm, in
is
the
it with me?
cone, now the total capacitance, sir, 1, 2, 3, 4, 5, 6. Is it 6, sir? 6 on one side, 6 capacitance are defined. Is it true, sir? 7 plates are there, 6. And is it 10 is 6?
Yes, N is 6.
But where is n is mentioned? I want to know the left side values, sir, or the
Oh,
n value.
this value. Oh, sorry, I should
That's
have.
right.
Yeah. So basically, what you are doing is, here you have to read the question here. So in order to perform the self test, and the C1 is not connected to the circuit. So here, this factor, this upper side, you have to ignore. Okay. So now the upper side. So I'll just draw it out here. So upper side you have to ignore right now. We are not connecting that. So okay. So now you have to just consider the stiffness of the beam. Upper side this is not connected. So the voltage. So the volt for the voltage equations you have to not consider this, but the stiffness will be so since this is not connected to circuit, these capacitors you have to ignore. So these capacitors which are there, you have to ignore them. Okay, but the stiffness, so the although the electricity is not coming in, the stiffness is already there now. So the material is there. So when the material mass is more, the stiffness will be there, right? So you find out the stiffness value. So to find out the stiffness value, you get the k values. So based on the k values, k values are the value for these beams. Okay. So from here you do it. So I is equal to TWQ upon 12. So T is 25. So that is the thickness given here. The thickness is 25 and each square is 5. So based on that we get the uh, and so what major factor is the length. So length here we are calculating. This is where we are calculating here. So a b c d like this. So the length is coming around 65 micrometers. So length we are getting it, and based on that we get the key equivalent. So now since the mechanical part you know you understood. So then we move to the electrical part. So electrical part, so we have how many capacitors here? 1 2 3 4 5 6 7 8 9. Sorry. In this in the normal figure I'll just check. Sure. So here, this is the first capacitor, first set of capacitor. This is the second set of capacitor. This is the third set of capacitor. This is the fourth set of capacitor. This is the fifth set of capacitor, and this is the sixth set of capacitor. So the n in this equation is 6 epsilon naught. T is basically uh, the distance between the uh, uh, two, uh, distance between the two plates, that is 5 micrometer, and d, obviously d is the gap between the two. uh, so,
Sir,
d
here
obviously is
B, sir, what, how much is the B, sir? Here B.
uh, just a second. So d is 5 micrometer. D is,
Five,
as you can
five,
see.
sir.
Yeah. So t is basically you have to count the number of squares. So you have to calculate like 1 2 3 4 5. So that is 20.
Sir, one more. I'm sure the figure, sir. The grill figure.
Okay. So you are not able to see it.
Yes, sir.
Yeah. So now just I'll just show you, just go in, so here we have the two capacitors. So this is the value of D, this is the value of B. So this is the value of B, and again this is the value of T. So uh, two capacitor plates D. Okay. So area of contact, uh, this is B, and the thickness of the plate is T. Are you able to understand?
Sir,
What are you able to
sir,
understand? So
now the overlapping area is, sir, I want to see the figure.
yeah, yeah. So
Some
overlapping.
overlapping area is there, na, sir. Now,
Yeah,
overall one, we are giving another deflection of 5. So we have to count the number of grills, na, sir.
yeah. You have to count the number of grids.
So now here already an overlap of 1, 2, 3, 4, 5, 6 is there, sir.
6, yeah.
Huh? Now we
Yeah,
are doing one more 5 nanometers, sir. So
yeah,
that will total be.
yeah.
Okay, sir.
So this question will take a lot of time. You just you try to solve it on your own, and then you just try to look at the solution. You'll get the answer.
Okay,
In case
sir.
any of these kind of this difficult question won't come, your exam will be more, mainly MCQ only. These are just to like test your brain. Okay. So any other questions?
Sir, when upper side is also connected, then
Then n
where
will
shall
fail.
we provide the two, sir? If upper side is also connected to the any voltage source, then
Yeah. If this,
how we can make the equilibrium in the
so
equation in the
so basically in that what you do is now, there are two options. So one, you can just remove, rather than multiplying by 2, rather than multiplying by 4, just multiply by 2, take a symmetry out of it. So basically what you do is you just by here where you are having 4, just take 2, you will get the same answer. And then
okay, sir.
maybe you can do it. You can, like, rather than going for anything else, what you have to do is you have to go by symmetry. And so the voltage will, you will get the value of V only, so you don't have to multiply the voltage by 2, huh? So understand one thing, you are not, you're just considering that this area is symmetric. So you are just taking symmetry, you will multiply this by 2, and what you will get will be the voltage, and that's it. You are not multiplying the voltage by 2, because the same way, voltage will be applying there, so as to get the symmetric, uh, what you can say, uh, symmetric displacement. Okay.
Okay, sir.
Anyone else has any other questions? If you don't have any questions, you can leave the call.
Sir, we have to do two, three problems related to assignment too, sir. If any doubt is coming, we will mail to you, sir. If mail is given,
Yeah, this what you can see here, ME22D503 uh, at the rate iittp.ac.in. I just put it in the chat.
okay, sir.
So you can see that in the chat box. Any other questions? In case you don't have any questions, you're free to leave the call. Um, if you have any questions, please unmute yourself and ask.
Sir, can you suggest any textbook, sir? S-
Like what? So whether you want to pass this course, or you want to like go into MEMS in depth. So
Actually, we have good library. Maybe I may try to find the books, sir. So that's why I'm asking.
no, no, like what is, like if you want to learn in depth.
That will cover our syllabus, sir. The basics
Yeah,
of.
no, actually, that's the thing. Like, if you want to learn more in depth now, so this is like basically in this course we are mainly going into like the superficial area of MEMS. So for
Okay.
this, you can just refer to the lecture slides and you'll pass the exam. If you want to go really into depth of MEMS, so there are two books. One is Mark Chemado. So I'll just show you. Uh, Fundamentals of Micro. So I'll just share the name here. So this is the major book you for MEMS. So basically, this is called as the Bible of MEMS. Then there is a more. So I don't think so that is like understandable. So there is one more MEMS Paul something. But that's not a very good book because what is happening is it was originally written in German and then it has been translated into English. So there are a lot of gaps. So unless so what will be happening is like in Germany, so they put voltage as U. So here we put voltage as V. They put a voltage as U. So a lot of those problems are there. So I wouldn't recommend that. So you go with Mark Gemado. The PDF is easily available on just you just search the book, you'll get the PDF. The thing is, for the exam, it is not very relevant. But if you want to go into the world of MEMS, that book is like a Bible. So, for exam point of view, I would suggest just stick to the lecture slides, whatever is given, and whatever the assignments and all we are doing. So that would be enough. If you are interested into MEMS, I would suggest you do it later after the exam is done. Maybe you can go into the world of MEMS. It's a fascinating world, uh, and this is one of the like the Bible for you. You can just go through it at your own pace.
Sir, I have a general note, sir.
Yeah, yeah.
Uh, recently means so 2 months back, we heard of an an accident in a house, na, sir, where the house is a sophisticated house with so many sensors. It is a very posh house. There might be all the sensor might be there. I think that.
Yeah.
But due to unfortunate fire in the maybe in the kitchen or something, the total house was burnt. Do you remember, sir, that in the North India? Uh, I read one point. That means what is my concern is even we are going to that much sophisticated sensors and IoT sensors, etc. If something is happening, later science in one YouTube, I watched that. The sensor may not be that is like he was not able to open the door.
Yeah,
I think
yeah. I remember what you're telling me.
so how to avoid those things? Even the house was with the sophisticated. Even we now we can take now Los Angeles fire accident. I think here they were not able to get the information quickly, like it is a danger and an alarm thing, and such that they can vacate their houses, na, sir. So
Actually,
even
actually,
we have
the
that
same
much
thing happened with
technology.
me also.
Yeah, it
So
is very pity thing to understand that we are not able to capable of avoiding those things.
So actually, that thing boils down to the design, how the thing is designed. So if you actually, what happens is, in like I'll give you example of my car itself. I have a Ignis. So what happened is, we have a fancy keyless entry and everything, and now start stop button. So now what happened is, the key actually was broken by my cousin. So he just broke the key. So now because the key electronic, so it has a key that senses whether the car senses whether the key is there or not, and then only it will start or stop. Now it doesn't have the keyhole. So like, no, how the normal old cars used to have a keyhole, by which we could start the car or stop the car. So the problem that happened with us also. So like because the key was broken, we could not use the car itself. So the car is functioning, everything is functioning, the key is there with us, but because the key was broken, the car couldn't sense the key, and because the key could not be sensed by the car, we could not drive the car uh, forward. So these things happen. So basically, it all boils down to the design and how the designer is thinking. So many times, the how the designer thinks is basically looking at the scenarios. So uh, why you can see the aircraft. So aircrafts are one of the most complex things. So what they do is they stress test everything. So what they do is they record everything, they log everything. So because they log everything, they come to know various scenarios that can happen, and because of these scenarios, like they know that what all can happen, and for every scenario they come up with a solution. So what is happening is, in our case, so in any other case, in case of consumer products, so earlier, if you have a washing machine in your home, you will see that there is a child lock facility. So what happened was, children would go inside the washing machine, and once a child has gone inside the washing machine, so that is why you have sensors on the door and all the things. So your washing machine will not work if the door is open. If your door is open and all these things, so you might have noticed with your washing machine. So what happens is, all these cases, the designer comes to know only after the tragedy is happening. So now that is some unfortunate thing about development. So when the people die is actually when the change comes. So although the people might have died in that scenario, in that horrific accident, so the designers have come to know that this scenario can happen. So in the next, when they will develop the next version of the product, they will put the safety features as well. So basically, that is like how the technology is happening. So whenever any development is happening, the development has a lot of people who have lost their life in that sense. So even you can say, even in the case of Titanic, so people lost their life, and that is why you could get a safer like materials for boat development. So that is how the thing happens. So unfortunately, though those people died, there will be a lot of improvement that will be happening, and that will lead to, like, there is no future loss of life in the future. So that is how the things work actually. So that is, I think I answered you. Maybe not the
Yes, sir.
satisfactory answer, but that is how it is.
Yes, sir. When the incidents are happening, we and the scientists all are trying to learn the problem and we trying to solve that one.
Yeah, so other scenarios that can happen, no, that will only happen if the things are locked properly, and if we keep a record of everything properly. So that happens. In India, we are not that very like thinking of all the things. So it depends. Now that is again a problem, that most of these developments are coming from China, where again the human life is not given that much of importance. So that is why nowadays you'll see that many of the products have become unsafe. So earlier, when the development would be from Japan or Germany or somewhere, uh, the human factor would also be taken into consideration. So the things were safer. So now, with China coming into picture and the designing happening in China, these things have become, so like many things have become unsafe. That is because in China again the life has no value. Like, so that is the problem. So unfortunately, that is how the thing is happening. Any other question, ma'am? If not, you can leave the session, ma'am. Any questions? Since we have no more attendees, I would like to close the call. I thank you for everyone for your attention, and for if you are looking at on YouTube, you can ask your questions on in the comment section of the YouTube video. Thank you. See you next time.